in some sense, the Newtonian innovation itself doesn't really count from basis 2, right? Because that was the very creation of science in the first place. Science in the relevant sense from which we're going to draw our template. Now, Michael recognizes that the Darwinian case is another outlier, at least he says so in the book, because, quoting him, the primary innovations were not mathematical in nature, and so there is no question at all here of coordinating or more generally constitutive principles in his sense. The principles that are missing so far, according to him, where quantum physics is concerned. We'll give him Lavoisier. We could argue about that, but we're not going to. Well, that's a fairly thin inductive basis, right? When I do economics, I try not to. I try to have more than 2 data points. Our alternative view is presented here. So, according to us, right, in quantum theory, right, the vanguard discipline, fundamental physics, that most successful empirical theory, and furthermore, the discipline that shades directly into metaphysics, if anything shades directly into metaphysics. Right? So if any metaphysics is to be possible, it should presumably be very closely and intimately related with our fundamental physics, which is now quantum physics. In quantum theory, the vanguard discipline arrives at full mathematicization and leaves the conceptual space projected through natural language and its metaphors behind. And this is, of course, much of the burden of our argument in chapter 1 of the book. That part of what is holding, according to us, part of what is holding back our full appreciation of quantum physics is our continued insistence to try to translate it into natural language. Right? We refer to that as domestication. Right? And we think that we argue that actually interferes in the case of quantum physics with understanding more of the world in a way consistent with it. Right? We keep trying to understand quantum physics in a way that's consistent with our understanding of the rest of the world instead of the other way around. Now, we certainly think that our account in Everything Must Go is only a way station. There's our metaphysical account. Is only a kind of way station, an incomplete, deeply and rather desperately uncompleted project, because, as we say in the book, it's in English. Right? The metaphysical content of our book is expressed in natural language, so we're sure it's got to be inadequate. And we look forward in the book to a day when metaphysics will be written in mathematics. And furthermore, where we'll probably need to use computers to do the metaphysics. Or more accurately, computers will do the metaphysics for us. That is to say, lots of the math that will have to be done for us to try and develop the metaphysics that is inspired by our best physics will be beyond the computational capacities of our biological endowment. And here, of course, we're alluding to Paul's work. We don't concede that this necessarily implies a loss of understanding. I mean, it would imply, obviously, if this future mathematical metaphysics was just projected onto the board to us now, we would have no idea what he was talking about. Right? That would certainly imply a loss of understanding to us now, but of course, that's not how it's going to go. Right? It will evolve, will develop, and the people's ways of thinking about metaphysics, their ways of thinking about what kind of understanding you should have of a metaphysics, what kind of understanding you should expect metaphysics to deliver, will evolve as people get used to thinking in the quantum world. It will, of course, imply a loss of understanding for people who can't do math. So this is, we're just talking about experts here. But we look forward to the experts of the future who will become not only, and by the engineering is important too, not just fluent with the mathematics of quantum theory, but also used to interacting with computational devices, with software, right? With information processing systems in ways we're not. So we look forward to them studying the equations and also thinking about how the computers were programmed. And saying things like, yes, I see how the universe is. They'll be wrong, of course, because that won't really be how the universe is. There will be metaphysics beyond that that will be different. But we can imagine them saying that and meaning it and it being a sensible thing to say. We do, of course, doubt that the metaphysical will be accessible to mathematically untrained, but I mean, Plato would have corrected that. To use Wilson's image, at that point, for non-mathematicians, for people who have not grown up programming the computers, basic metaphysical concepts will indeed have drifted out to sea, but they can take some solace, if they're willing to be humble, when the experts radio back from their observation planes over the sea that Scuffy, the tugboat, is afloat out there. Remember in Mark's, in the children's story in which Mark feels Scuffy is rescued before going out to sea. Maybe Scuffy can manage of it. Now, I'm going to shift gears at this point. I'm going to make what will look like a digression, and then come back to this dialectic with Michael at the end. I'm going to shift into the digression through the vehicle of another quote from Mark. When discussing the prospects for unifying, in some sense of unifying, classical mechanics, Mark says, he's discussing here Hilbert. He says, who might have conceived in Hilbert's day that it is through quantum mechanics, right? This is in the italics on Mark, right? Quantum mechanics of all things, that classical doctrine would find its unity. Now the scare quotes on unity make this a slightly sly remark. Right? That is to say, we take the scare quotes to indicate that Mark's distancing himself from the sense in which quantum physics unifies classical mechanics. It unifies it in a strict sense, in a technical sense. But we take it there's some distancing from the desirability of the project of unification as it has been conceived by many philosophers. Now what's the source of that distance? What's the explanation of that distancing? I take it one story one might tell, one reason one might have for wanting to take a little bit of distance from the idea that quantum mechanics could unify classical physics in the sense that Hilbert imagined classical physics might be unified. Right? One reason one might think that there's been a kind of shift in what the unification project comes to when you postulate foundations of classical mechanics and quantum physics. These worries about the kind of future metaphysics done without natural language that I just spoke about. So suppose one accepts that we're moving in this Humphreys direction. Why is it happening? Obviously, I think quite clearly the main reason, one of the main drivers of this Humphreys thing is the exploding number crunching capacities. But there's another reason too. There's another basis for the changes we are now observing in the way science is organized and the kind of understanding in the traditional sense, in the sense traditionally thought relevant to metaphysics and unification under a certain understanding of unification. There's another reason why this is changing, and that is that Michael alludes to this a number of times in his book, the increasingly distributed nature of the conceptualizations that underlie research projects in science. And now I'm thinking, I mean, physics certainly, right? One now, it's a commonplace that one now regularly observes physics articles with 80 authors. But also outside physics. In fact, particularly, and this is directly related to the emphasis on statistics crunching in special sciences,